Hey everybody, Mr. Rubo here. Today we are going to start things off with just a little introduction to sequences and series. So the first thing will be just a couple definitions. So sequence is a function whose domain is a set of consecutive integers. If a domain is not specified, it is understood that domain begins with 1. The values in the range are called the terms of the sequence. So you can kind of see here our domain starts with 1, goes up by 1. That's what's making this a sequence. Its range, we just call the term. So here's a finite sequence where you have 2, 4, 6, 8. The first term is 2, second term is 4, third term is 6, fourth term is 8. Okay, so the domain would be 1, 2, 3, 4. This right here is your range. So a sequence is any function that we can define with the domain of the set of consecutive integers. Okay, so that was finite. Infinite, on the other hand, what it sounds like, 2, 4, 6, 8, comma, dot, 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 meaning it goes on forever. So this would be the positive even integers would be what we would call this sequence. But once again, the 2 would be the first term, 4 second term, so on and so forth. You can use kind of the same idea how we write equations with functions. You can do the exact same thing. Sometimes instead of saying equation, we also say rule when it comes to sequences, but really they're the same thing. So here you can see the rule. We write, we just have slightly different notation. So we say a sub n, meaning the nth term, equals 2 times n, meaning whatever n is, whatever term we're looking for, you're going to just substitute in n, and you'll get the term. Or you could write in function notation, and it looks the same. So let's scroll down a little bit, so you might not have been able to see that. We'll see. So here's an example to write the first 5 terms. So it says a sub n equals 2n plus 5. So we're going to find a sub 1, which is literally just putting in 1 for n. So 2 times 1 is 2 plus 5 is 7. So there's our first term. A sub 2, we substitute in 2. And you'll get 4 plus 5 is 9. A sub 3, 2 times 3 plus 5, so that would be 11. And you probably already tell what the pattern is, so you don't necessarily have to keep doing the algebra. You can just, once you figure out, oh, I'm going up by 2's, so you could probably guess here without substituting in that the next one's 13, but just to check, 2 times 4 is 8 plus 5 is indeed 13, and the last one is going to be 15. Okay, so yeah, you can kind of see here whenever they ask you for, so many terms, once you see the pattern, you don't have to necessarily do the substitution. You could just follow the pattern. Okay, now the pattern is not always going to be addition. It's not always going to be multiplication or division or subtraction. There's lots of different types of sequences out there that we'll see the rest of this chapter. Okay, so I want you guys to try B. So take a second to pause the video and try it out. And if you have questions, we'll go over in class. Alright, cool. So hopefully you did it, and we're going to move on to example 2 here. So here's kind of going the other way. So it says describe the pattern, write the next term, and write a rule for the nth term of the sequence. So usually describing the pattern's not too difficult. You just kind of look, like I said, it's not always multiplication, not always addition, not always subtraction, but it's usually not too difficult, at least in our class. So here you can hopefully see 4 to 7, 7 to 10, 10 to 13. Those are all adding 3. Okay. Now, the trickier part is to come up with the rule. Well, I guess let's write the next term first. So the next term would just be 16. right? So we have the pattern, we have the next term. Now coming up with the rule is where it gets a little trickier. But if you use your mathematical knowledge and maybe even like previous examples here, you can see when we were adding 2 every time, we had a linear function and we had a slope of 2, and that's what we were adding every time, which should hopefully make sense when you think about it, because your slope, every 1 over, you're going up 2, which means that range increases by 2 as your x increases, or your n increases by 1. So that means for a sub n, our slope here is going to be 3. Okay. Now we have to figure out what we need to add to this, though, to get 4 as our first term. Because remember, we want a sub 1 to equal 4. Well, if we plug in 1 right now, we get 3. So to go from 3 to 4 with addition or subtraction, you add 1. Now we just wrote our rule. Sometimes it's a little tougher than that. It just depends. Okay, and we'll learn a little bit more about specific types of sequences and then their patterns and their rules throughout this chapter. Okay, so let's look at this one though, because this one's a little different. So here, 2, 4, 8, 16, and then it switches from negative to positive. So that means we're going to have multiplying by -2. Okay, and the negative is what makes it switch back and forth, and then obviously multiplying by 2. So the next one would be -32. Now the tricky part comes in once again here, at least right now, because we are just starting these, is coming up with that rule. So you have to think about, okay, well, we're multiplying by -2 every time. So if you're multiplying by a if you're multiplying something over and over again, that's an exponent. Alright, so -2 to the n is actually what we're going to end up getting, because the first one, when I plug in 1 for n, I get -2. When I do 2, that's like me multiplying by -2 again, and that's going to be to the n. Squared. And so that's going to be +4. Okay. Like I said, we'll get to finding some of these a little easier than just kind of a guess and check kind of method, but we'll get there. Alright, so I want you guys to try these last 2 here. I'm going to make it so you guys can see them a little clearer. So come up with those next terms, write the rule, and just describe the pattern. And you can kind of see with the describing of the pattern, I even just wrote it mathematically. You could write it in words if you want. But so yeah, take a second, pause the video, work out those. Okay, so hopefully you did that. And the last thing, so I said it was introduction to sequences and series. So we've done sequences now. Let's talk about a series. Well, a series is just when you take a sequence and you add all of the terms together. Okay, that is what we call a series. Just like a sequence, it can be infinite or finite. So finite series, 2 plus 4 plus 6 plus 8, that's a finite series. Infinite series, 2 plus 4 plus 6 plus 8 plus ... There you go. Now, instead of writing out that whole sequence, that whole series, we like to use what's called summation notation to write these. So here's 2 examples. So for this one, the 2 plus 4 plus 6 plus 8, we use this big Greek letter called sigma. We're starting at 1, so we're saying n equals 1. The last term, so there was 1, 2, 3, 4 terms, so the last term was 4, so 4 goes up there, and then you put the rule, the sequences rule, there. Okay? So if it's infinite, though, you still start with 1, normally, but then you're going to infinity because it doesn't have a final term. It just keeps going on forever. The rule, though, is the same because it's the even integers, or sorry, positive integers. So for both series, the index of the summation is n, and the lower limit of the summation is 1. The upper limit of the summation is 4 for the finite, and infinite for the infinite series. So let's write a couple of these in summation notation. So here you can kind of see, oh, we're going up 25 each time. So we have to first come up with the rule. Well, the rule for a sub n is just going to be 25n. Nice and simple one. So now for the summation, though, use the big old sigma. N equals 1 on bottom, 25n here. Now we just have to figure out what's going up here. Now, big mistake that I see is people just put 250. 250 is the term. We want the term number. So we need to figure out what n value will give us 250. You can either think about it. Oops, did I not change colors? I could have sworn I did. Whatever. Oh, there we go. So we want to know what n value will give us 250. So we just set the sequence equal to the number, and we solve, and you can hopefully see that n equals 10. So that means 10 is going up there. And there's our series. Okay? So I want you guys to try these ones. Just pay attention if the dot 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 is at the very end. It's an infinite series, so you have infinity on the top. You just have to figure out what the rule is. If there's a final number, you're going to do exactly what we did just there. Alright, so like I said, take a second, pause the video, and work through those. Alright, last type of problem we're going to see is when they actually already give us the series, and you have to just figure out what the sum is. So here, you just have to pay attention, because in both of these cases, they actually don't start at 1. So you just have to make sure you're paying attention to that. But the nice thing is, you're just going from this number to this number, counting up by ones, and you're substituting them in. So you're going to say 3 plus 2 squared plus 3 plus 3 squared plus 3 plus 4 squared, and finally 3 plus 5 squared. Then you just do the calculations and then do the addition. Okay. This one, same idea. Substitute 0, 1, 2, 3, 4, 5, and then add up your answers. Okay. So just to finish this one off, so 3 plus 4, 9, 16, 25, 7, 12, 19, 28. Now the reason I did that was so I can see each the number in the sequence, in case they asked about it, like if it was, you know, the previous question or something. So I know in this sequence, the 3 plus k squared, it would go 7 plus 12 plus 19 plus 28. Now I'm just going to add them together. So that'd be 19, 38, 66, I believe. I did my addition correctly. Okay. So yeah, there's my work, and I want you guys to go ahead and try part B, and that is where we will call it for today. Thanks for watching, and have a good day.